So you have 1 unit of electricity creating 1 unit of heat. With a heat pump, that 1 unit of electricity can be used to create 3 or 4 units of heat. So you have the potential to dramatically cut your heating bills. Most heat pumps are designed to be able to heat the home to 21 degrees when it's -3 degrees outside. That's how they're calibrated. I'm delighted with my heat pump. It works great. It heats the home in a much nicer way. You don't get this kind of heating up, cooling down. It's just lovely. It's like being in the Mediterranean all the year round. It's cheaper to run. I'd like to see the government being even more ambitious with the loan and saying something like, for the next 200,000 heat pump installations, we're going to pay £15,000.
Hi, Tom. Very welcome again to the podcast Sustain Change and Grow, and continue our discussion that we started last January, February.
Yeah, well, it was a lot of fun last time, so I'm looking forward to this.
Just to remind to the listeners, in the episode 20 on the middle class approach to decarbonization, we discussed how Tom took a pledge to reduce his family's house carbon footprint by 50%. And all the actions that he's taking or he has taken on the way. We discussed a lot of different things last time, and we even didn't have time to talk about the heat pumps, which seems to be a big saga actually. And so this episode will be dedicated to the discussion about heat pumps and their role in the fight of the climate change. Okay, and say maybe we start directly here, and Tom, you tell some words about indeed the role of the heat pumps in reducing carbon emissions.
Home heating is in most countries around 15% of remaining emissions. So there is, and most home heating happens through fossil fuels in the developed world. And in the UK, that's typically gas. In other places, you have kind of oil fired. And so, getting us home heating kind of off those fossil fuels is going to be a really important challenge if we're going to get anywhere near net zero. By contrast, the thing we've done quite well is to decarbonize electricity supply. So, I mean, France has done that for a long time through nuclear, but wind and solar and so on. So we need to find a way to shift home heating from fossil fuels to electricity, because if we can generate a lot of low carbon electricity, then kind of we'll be fine with that. Heat pumps are really important because they provide a way of using electricity extremely efficiently to provide home heat. Because the problem is that if you simply use electricity in kind of resistance heaters, either in an immersion heater for water or just a sort of an electric boiler, it's vastly more expensive than gas. But heat pumps are a way of kind of driving up the efficiency of electricity use really, really dramatically in a way that makes it broadly cost competitive with gas. So, heat pumps, I think, they might not be the only solution to home heating, and it's a fiery debate with kind of people getting very emotional on both sides. But I think it's pretty clear that heat pumps are going to play a significant role in decarbonising home heating.
And still we see quite a low uptake, no? Like it's about 10-15% of the market.
Yeah, it is low uptake. I mean, the UK government has set a target of 600,000 installations a year by 2028, which is not very far away. And at the moment, there are only a tenth of that. 60,000 were installed roughly last year. And, I think there are a number of challenges that we might come on to, but I think it's proving quite challenging to sort of get the supply chain up and running, get the demand to a scale where economies of scale can kind of take over. And actually, that was one of the reasons why I decided to sort of venture on this. So I'm a sort of, in UK terms, a relatively early adopter of heat pumps, although it's a very mature technology. I mean, these things have been around for decades and are widely used in Scandinavia, for example, but also in commercial building heating and cooling. So it's not like a new technology, but they're not used in homes that much, certainly here. And so I thought this was a useful thing to kind of deploy some resources to try and help in a very small way, kind of send some market signals and also from a personal interest point of view, figure out, what needs to happen in order for this adoption to increase, by an order of magnitude, which is what's going to need to happen.
While preparing for this episode, I read that there was a heat pump installed in the Zurich City Hall during the 1937-38.
Right.
It was replaced only in 2001 by a
Wow.
more efficient one. So like 63 years old.
Okay, so they laugh. That's that's great. And I think I think what people sometimes don't understand is, I mean, heat pumps, they're used in fridges. Like I say, commercial buildings uniformly use heat pumps. I mean, they're used absolutely everywhere, but we've not yet quite found the trick of translating that on scale into their use in domestic properties.
Yeah, and this is surprising because actually most people I have talked to, they never heard about heat pumps.
Mm,
Doesn't matter in France or in Russia, the knowledge about this technology, which as you said is not recent at all, is not very well known.
mm.
The heat pumps can be used both in the like private houses, but they can be used also in the apartment buildings.
Yes, they can. If you use them in private housing, then typically each house will, as it were, have its own heat pump. It will be a completely kind of separated system. If you use them in apartment buildings, typically the apartment building will operate with some sort of heat network that operates throughout the apartment buildings that would kind of share the use of kind of larger heat pumps. But they're perfectly possible to use. I think it's fair to say that it's probably a little bit more difficult to retrofit a heat pump into an apartment building, because you may well face challenges around actually where do you put the external unit. But if you're building an apartment building from new, then absolutely, heat pumps are almost certainly the most effective way of heating them. And of course, the wonderful thing about heat pumps, which I think is an underemphasized benefit of them that could really help encourage people to take them up, is that you can reverse a heat pump and you can make it cool. So heat pumps work in both directions, and so as we come into an environment where more and more we might want to be able to cool at least one part of the house when it's 40 degrees outside in the summer, then actually heat pumps can do that in a way that a gas boiler just simply never will be able to.
Yeah, that's where I was going to, because I saw some photos where heat pumps look almost like air conditioners, like these big boxes which are outside of the building, and they look like individual apartment devices, let's say. Exactly. So people are actually now investing quite a lot in installing air conditioners. Then the question, why not install a heat pump instead, which will serve both ways?
Yeah, absolutely. And I think this really gets to, yeah, cause, I mean, because all heat pumps do is they move heat around. Okay, so heat pumps don't kind of create heat, or air conditioning doesn't kind of destroy heat. They just move heat around. So when a heat pump is working to heat your home, it takes heat from outside of the home and concentrates it inside of the home. When it's cooling the home, you basically just run that cycle in reverse, and you take the heat out of the home and you dump it outside. And it's because of this fact that heat pumps aren't actually creating heat, they're just moving it around. That's what makes them so fantastically efficient. And unfortunately, I think regulation hasn't fully caught up with this. So for example, if a heat pump is going to qualify for the boiler upgrade scheme in the UK, which is a government subsidy for introducing heat pumps, you can't use it for cooling. And this seems to me to be absolutely bonkers, in the sense that it's this idea that it's meant to be an energy saving measure and we shouldn't be encouraging people to use air conditioning. But actually, most important is to encourage people to take up the technology. And if people want air conditioning, they're going to put it in anyway, right? So let's just go with the grain of that and use that as a sales benefit for why heat pumps are a useful thing to use.
Yeah. On the other hand, while we may not want to encourage people to use air conditioning, the temperature are getting hotter and hotter, and the buildings are not foreseen for this, and people will use it anyway, or they will use fans and other devices.
Absolutely, that's completely correct. I mean, it is worth sort of maybe getting into a little bit of the kind of technicality around the difference between the heating and the cooling of a heat pump, because the way that heat pumps are typically deployed in the UK market, certainly, I can't speak authoritatively. Actually, I think it is quite different in the US, but in the UK market, we have central heating systems that carry the heat around using water. And water is carried around through radiators. And we've traditionally used a gas boiler to heat up that water before we move it around the radiators. And so the way heat pumps are typically deployed in the UK is that you replace your gas boiler with a heat pump and you just use a heat pump to heat up the water, and the water then travels around the house. When heat pumps are in cooling mode, they work completely differently because typically they just cool air, which is pumped directly into the home. So if you stand by an air conditioning unit, then actually, you just feel cold air coming in. It's not that there's a kind of cold water running around the radiators. It's just cold air coming straight in. And actually, when they're used for heating in commercial buildings, again, heat pumps typically just heat the air and then that air is circulated. So there is this slight difference in how they need to be kind of implemented for heating and cooling. And I think that's something that needs to be given, much, much more thought about how we can do that effectively to give heat pumps this double use, which I think will immediately make them much more appealing to consumers. Because at the moment we're in this place where, clearly insufficient numbers of consumers think that heat pumps are going to be an improvement to their lives. And maybe we can talk about kind of some of the things which I think are kind of myths which block people buying them. But I think anything we can do to make them more attractive to consumers is well worth thinking about. And indeed, if we look forward to kind of the world of renewables, this problem about people using air conditioning in the summer may be much less of a problem from an energy efficiency point of view, because we may well have excess renewables in the summer. Because I think the point is to have enough energy generation to get us through the winter. We're almost certainly going to have excess electricity generation in the summer. And so if we have a few people using a bit of air conditioning, then maybe that doesn't matter.
We will certainly get to the myth. Let's first maybe discuss a little bit more on the technicalities, explaining a bit more the heat pumps. So I understand there are different types of heat pumps, right? So something that you already mentioned, there is air to water or air to air. Maybe you can just explain a little bit these specificities.
Yeah, I mean, so it's maybe we're taking a step back and going back to this point about what heat pumps actually do. So heat pumps do not, when they're in heating mode, they don't create heat. They move heat from one place to another. So you can kind of think of these little heat fairies kind of going around collecting little bits of heat from whatever source, and then they concentrate it into whatever it is that's being heated. So heat pumps work in different ways depending on what the source of the heat is and depending on what it is that's being heated. So let's start with the source. So the two most common sources of heat that are used are air source heat pumps and ground source heat pumps. So with air source heat pumps, really what the heat pump does is it gathers heat energy out of the air, and anytime the air is above absolute zero, which is minus 273 degrees centigrade, there is some heat energy in the air. There might not be that much of it when it's very, very cold, but there is heat energy that can be gathered and concentrated, whatever the temperature. So if there's an air source heat pump, it's concentrating that energy out of the air. A ground source heat pump gathers energy out of the earth. So you kind of dig a borehole, and you have your kind of heat exchanger operating in a way that gathers heat out of the ground. The advantage of that is that the heat of the ground is much, much more consistent around the year. So even if it's got to -4 degrees in the air, if you've drilled, I don't know, 30 meters down or something into the ground, actually they don't go that deep, but if you 10 meters down, let's say, then it might well be 12 degrees at that point. So there's much more consistent heat around the year, and that can enable ground source heat pumps to operate more efficiently. So, and actually, you can get energy out of rivers. That's another one that's often used for industrial heat pumps. They might use a river as a source of heat energy. So these things, that one of the things that people find it difficult to understand with heat pumps is that things that we consider to be cold, like going into a river or the air outside when it's sort of a cold day, these things still have heat energy in them that can be captured by the heat pump. So then the next thing is, well, what's the heat going into? And when you're talking about heating homes, there are really two main options here. One is that you just heat air directly, and then you just pump air around the home. And that's how it works in commercial buildings. In the US, that's very, very common. They'll have, because they've generally combined heating and cooling from, quite a long time, they use kind of air vent systems that operate around the home. But as I was saying, typically in the UK, we use that heat that we've gathered out of whether it's the air or the ground, and we use it to heat water. And then that water is then pumped around a radiator system, and that's used to transfer the heat around the home.
Mhm. Which is also very useful because we need hot water anyway. So we can use it also for the water use.
You can use it for heating your hot water as well. One of the challenges with heat pumps is that there's this sort of magic that a heat pump does, which is that for every unit of electricity you use to run the heat pump, because it's not using that electricity directly to create heat, it's using it to gather heat from other places and move it around. You can actually end up with much more than 1 unit of heat energy for every unit of electricity that you use. It's one of the reasons why heat pumps are so fantastically efficient. And we need them to be efficient because per unit of power, so per kilowatt hour, which is the typical unit of power, electricity is about 3 times as expensive as gas, or maybe even a little bit more. It depends on the country you're in. So on the face of it, we need to be using this electricity really effectively to make it cost competitive with gas. The problem is that heat pumps work most efficiently when you're asking them to heat stuff a bit rather than a lot. So a heat pump will work much more efficiently if it's heating water to 40 degrees C than if it's heating it to 70 degrees C. And so, yes, you can use them for hot water, but that's one of the things that creates a drag on efficiency because we tend to want to have our hot water a little bit hotter than 40 C. And we've also come used to running our radiators extremely hot as well. So there is a bit of a mindset change that's needed in how to use heat pumps in order to make them operate efficiently. And we need them to operate efficiently so that they become cost competitive for the consumer with their gas boiler. Because what we don't want is people putting in a heat pump and then thinking, "Oh, this is far too expensive." So, there are some subtleties that in the operation.
For example, in France, about 37-40% of the houses are heated using the electricity. The electricity in France is mostly low carbon, so it's nuclear.
I mean, so if you have a country where direct electric heating is commonly used, then that should be a really really fruitful area for looking at heat pumps because when you are using electricity directly, whether it's in storage heaters or other forms of electric heaters, and when you're using an immersion heater to heat your water, then 1 unit of electricity converts into, well, probably zero point 0.9 units of heat because you lose a little bit of efficiency through the system, but let's call it one. So you have 1 unit of electricity creating 1 unit of heat. With a heat pump, that 1 unit of electricity can be used to create 3 or 4 units of heat. So you have the potential to dramatically cut your heating bills. Now, there's a capital cost of installing the system, of course, and that's one of the barriers, I think. But really, you should have a relatively short payback period if you're switching from electric heating to use of a heat pump.
And is it a must to have green electricity or low carbon electricity to install heat pumps and get the most of it?
Well, I mean, that's a really interesting question. I mean, I think if all your electricity is produced by gas, then the question becomes: is it better to use a gas boiler or a heat pump from a carbon point of view? I think that's what's behind your.
Exactly.
And the answer is yes, it still is. In that, if you use the gas to replace electricity to use electricity because of kind of inefficiencies and lost power losses over the transmission of the electricity, you kind of need to use twice as much gas to create this, a particular unit of power than you would if you used the gas directly in the home. But on the flip side, when you apply the heat pump to that, they for you actually get 3 times as much heat power from those units of electricity. So the way it works out is that even if you were using electricity entirely generated through gas, you'd cut your carbon footprint by about a third if you had a heat pump compared with burning the gas directly in your home. And of course, by burning the gas directly in your home, you're also, releasing pollution and particulates in a completely uncontrolled way through your gas boiler. Whereas if we're burning the gas in a central location at a power station, we have more opportunity to capture and manage some of those pollutants. So, even if we didn't have renewable energy, I still think it would be, from a carbon perspective, worth using a heat pump. But obviously, it becomes a real kind of win-win when you also have renewable electricity. And and I think one of the challenges that's often placed around heat pumps is, oh well, we'll need this vast amount of renewable electricity, so we're going to replace everything that we currently do by burning gas with generation of electricity. Then we're going to need these enormous kind of tripling of renewable capacity, and the grid will never cope, and so on and so forth. And there is something in that argument that needs to be considered. We really need to consider how we're going to deal with those capacity upgrades. But I also think that heat pumps provide a really great opportunity for managing heating demand. So the way a heat pump works is that, unlike a gas boiler, so the way we tend to operate gas boilers is that we blast a load of heat into the house for a couple of hours to heat it up, and then the heating goes off and the house cools down again. And then a few hours later, we blast another load of heat into the house. With heat pumps, you just trickle heat into the house all of the time in a way that matches the amount of heat that the house is losing. So you really do this kind of slow and steady approach to heating. And actually, what that means is that, if your heat pump just turns off for an hour or two at some point, it doesn't really matter because it's just doing this slow and steady heating. So I think there's a great opportunity actually for just slightly synchronizing networks of heat pumps in a way that actually they're not quite all operating at the same time, particularly in a way to manage demand peaks in the electricity system. So it would be quite easy, for example, to organize heat pumps so that they weren't operating during peak hours when people return home and cook their dinner, for example. It would be quite easy to do that, and you'd have no loss of comfort in the home. So I think there's lots of really intelligent ways that we can use heat pumps for system management, as well as the direct carbon benefits of their greater efficiency.
Let's move then to the myth, the question that comes: do we have to bear the cold in the house and wear hats and scarves, etc., if we install a heat pump?
I mean, this is something you really hear this frequently about heat pumps. That, oh well, they just don't work in cold weather, or they don't work in British houses which aren't very well insulated. And I have to say, this is actually a nonsense. And I mean, I think we need to remember that these are used to a widespread basis in Scandinavian countries which aren't known for their kind of warm and sunny climates. And in my own experience, very personally, I have a 1930s house with a solid brick wall, which isn't brilliantly well insulated, and I've operated my heat pump down to external temperatures of -3, -4, and it copes absolutely fine. There's absolutely no problem with heating your home with a heat pump, however cold the weather gets.
What is the temperature that you get at home?
Yeah, well, I mean, you can set it to whatever you want. I mean, a heat pump will. I mean, I set my thermostat at 20. So I used to set it at 19 when I had a gas boiler, because my family were a little bit skeptical about this experiment of putting in a heat pump. I wanted them to experience a warmer house after the heat pump. So I then set the thermostat. I nudged it up a degree to 20 degrees, but normally it's between 19 and a half, 20 degrees. But most heat pumps are designed to be able to heat the home to 21 degrees when it's -3 degrees outside. That's how they're calibrated. And since we've had the heat pump installed, we've had very cold weather, and it's had no problem keeping that temperature. The challenge with them, which maybe we'll come on to, is that you need to have them operating in that way that's efficient and not more costly than a gas boiler, and that's one of the challenges around it. But they definitely work when it's cold.
Are there any other myths?
Yeah, I mean, there's a couple of myths that you hear quite a lot. One is that they're noisy. And I think, you can think of kind of rattly old air conditioning units, and you might think, oh, yeah, that's a bit noisy. I'm not sure I want that going off outside my house. I think modern heat pumps, and if they're well maintained, are incredibly quiet. I mean, it's quite difficult to tell when our heat pump's on. It's definitely quieter than our gas boiler flue when the gas boiler is operating, and actually it's quieter than my neighbour's extractor fan that they have in their kitchen. So I think this noise point is really overstated, and in fact we just don't have a level playing field around kind of noise planning restrictions in relation to heat pumps. So I don't think they're noisy. And the other myth, and this is a really important one, is that they have higher running costs, and people that install heat pumps have massive bills. Now, this is a more challenging one. So I would say that has not been my experience at all. So since I installed my heat pump around the turn of the year, my energy bills compared with the prior 2 years, my total energy bills are 25% lower nearly. Now that's going to get a little bit worse again as we get into winter because heat pumps are less efficient in winter than they are in summer. But my best estimate is that I'm going to be saving 10 to 15% on my annual energy bill since introducing a heat pump. So it hasn't been my experience that they are costly. However, the problem with heat pumps, and I think, is that you have to have them well installed because of this point that a unit of electrical power costs about 3 times as much as a unit of gas power. The efficiency of your heat pump needs to be generating at least 3 units of heat energy for every unit of electric energy. And if it isn't, then you do run the risk of high bills. So I think one of the challenges with heat pumps is that they need to be installed to high quality in a way that enables them to operate efficiently. But that is perfectly possible, even in homes that are not terribly well insulated and even in cold weather. And I think that as we kind of gain in experience, and actually, I think recent technology improvements in heat pump design have dramatically improved their efficiency. So we see there have been some heat pump studies done by the UK government looking at efficiency of installed heat pumps, and they find a wide variation. They find an average efficiency of about kind of 2.8 units of heat for every unit of electricity. But with the improvement of heat pumps, and the technology in heat pumps, I mean, I think that's going to rapidly move the average well above 3. And so this problem about high bills is only going to arise when you have genuinely very poor installations.
Installation works a must when installing a heat pump?
I think this is a bit overstated, personally. I mean, obviously, we should be, trying to insulate our homes to a good standard. But heat pumps work even in homes that aren't that well insulated. I think the point is that you want to be operating your heat pump at the lowest possible temperature because then it's as efficient as it can possibly be, and then it's going to be as cheap as it can possibly be. And what determines the temperature that you need to operate your heat pump is the heat loss from your home. So the more heat you have leaking out of your home, the higher the water temperature you need in your radiators to compensate for that heat loss. So obviously, if you have more insulation, you lower the temperature at which you need to operate the radiators, and that means your heat pump is more efficient and everything becomes cheaper. But as I said, if I think about my own home, which is a detached home, one complete side of the home is the original 1930s solid brick wall, which is not well insulated. The ground floor has suspended wood floors, which do not have underfloor insulation in them. There are bits of the house that are better insulated. So we had a loft extension, so our roof is quite well insulated, but it's by no means an amazingly well insulated home. But it's still perfectly uh, usable with a heat pump. And I think that it's a mistake to think that people need to do incredibly expensive work ripping up their floors, putting external insulation on, and so on and so forth. I think you do need a house probably with double glazing and decent roof insulation. I mean, I think those are probably the kind of minimum requirements. But I think once you've got that, I think that a heat pump will work fine in most homes.
Can you use a heat pump with your individual solar panels?
Heat pumps work brilliantly with solar panels. And so I've been a little bit kind of confused about why I'm saving so much money on the ongoing running costs after having a heat pump, because I was expecting it to be roughly neutral rather than making a massive saving. And I think one of the reasons that I'm making a big saving is that heat pumps and solar panels just go together beautifully, particularly in spring and autumn. So, I mean, the first thing is the vast majority of energy you use in a heat pump is heating the home. I mean, hot water is a relatively small percentage of it. So it's heating the home that really counts. And what you get in spring and autumn is that you get a need for heating, but you also still get quite a decent amount of sunlight during the day. And so what that means is that this solar energy, which previously was, not really being used very effectively, gets deployed very efficiently to run the heat pump. So actually, you are doing a lot of your heating for free with the solar energy. And it's a very efficient way of using that solar energy because, I mean, a lot of people have a device for mopping up excess solar generation, which involves putting it into the immersion heater in your hot water tank and using spare energy to heat up the hot water. But there you're just getting 1 unit of heat energy for each unit of that excess solar. If I'm using the excess solar to run my heat pump, I'm getting at that time of year probably 4 units of heat energy from each unit of that solar energy. So they're an absolutely magical combination with solar panels.
Yeah, and if I understand, your solar panels were installed before. It's not like you have to make investments at the same time and make some sort of a combined system.
No, although I mean, we've had our solar panels for about 8 years. I mean, I have to say, of all of the kind of, if you're looking at financial paybacks, solar panels are the things that really do pay back financially. I mean, I think heat pumps, even with our reduced heating bills, I think heat pumps are not a kind of a commercial proposition, if you like. It's a long payback period, but I think there might be some interesting stuff to do. I mean, if we really wanted to help consumers get a great experience from heat pumps, if there were ways of sort of developing financing packages that involved combined installation of solar and heat pumps, I think it would be a way of ensuring that actually the overall costs to the consumer are much lower. And I think that if we had the development of companies, I mean, there's this sort of idea of heat as a service, which is developing in the energy industry. So at the moment, we have this idea that we buy energy, and then we use that energy to create heat, and then it's kind of on us how much energy we use in creating that heat. But you could have heat as a service, where what you do is, instead of buying energy, you buy a service that keeps your home at 20 degrees and heats your water, and that's the service that the company's providing. And then the company is managing the risk for how that is done. Now, the reason that's potentially a smart idea is that a company may have the resources to be able to undertake the investment to simultaneously install a heat pump and solar panels in a home, because they don't mind if the payback is 7 years, because they're a big commercial organization with a strong balance sheet and they're used to thinking in those time horizons. Whereas for a consumer, coming up with the money to put in a heat pump and solar panels at the same time, for the overwhelming majority of people, is a prohibitive capital investment, even if it's got a positive net present value over a decade. So, I think there are some really interesting possibilities of combining some of these technologies together.
You already started touching about the policy implications, but
Mm.
before getting there, because I think many of the policy implications you came to are really coming from your personal experience of installing the heat pump, right? So maybe you can tell shortly your long saga.
I'll keep it short. I'll keep it short. I mean, yeah, I mean, there is this at the moment. There is this sort of disconnect between the policy intent around heat pumps and how consumers actually experience it on the ground. So, one of the problems that you may well run into installing a heat pump relates to planning, because what you need to do is, as you've highlighted, you need to install an external unit that looks a bit like an air conditioning unit. And it is basically an air conditioning unit. And actually, if you've got a larger detached home, you may need a double-sized one of those units. And so you immediately run into the question, well, where do I put this thing, right? And most people want to put it down the side of their house, because you don't particularly want a large air conditioning unit sitting in the middle of your patio. But then you run into the problem that if that unit is within a meter of your neighbours of the boundary, as it is with many houses, even detached houses, then you need to get planning permission. And then, so we were in that situation. There was nowhere at the back of the house we could reasonably put the heat pump. And so we wanted to put it down the side. It was within a metre of the neighbour's boundary. So we had to get planning permission. And then when you get planning permission, you had to get a noise survey, where they come out and monitor the noise that the heat pump produces compared to the ambient noise. And if the heat pump is above the background noise level, essentially they look at the kind of quietest 10% of periods in a 24-hour period. And if your heat pump makes more noise than that, potentially when it's at maximum, then they can remove the ability to give you planning permission. And so, the saga we had was that immediately you incur costs by going for planning permission and having to commission a noise survey. But we also had this problem where, even though we live on a busy road, they said to us, well, in theory, your heat pump could be noisier than the background noise in the middle of the night. And this just sort of drove me absolutely nuts because, firstly, even though that may be true, the heat pump generally doesn't operate at night because typically you have a lower temperature at night than you do in the day. Secondly, when it is operating at night, it's because it's bloody cold and everybody has their windows shut and you can't hear the thing. And thirdly, if it's cold and my boiler operates at night, it sounds like a plane taking off when the boiler fires up. It's far more noisy than the heat pump. So we've got these completely sort of asymmetric kind of treatment of boilers and heat pump around planning regulations. So I think that we really need to get an alignment of the planning system in a way that supports the presumption that we want people to install a heat pump rather than supporting the presumption that this is going to be a noise nuisance. And I think Nesta, which is an innovation non-profit that has been looking at heat pumps, I thought came up, which is a really excellent idea, which is that currently noise standards are created by monitoring the noise output at certain distances, from a heat pump, and you need to get a noise engineer to come and do that survey. Instead, you could just have a target maximum noise output from a heat pump that would just enable you to know from the design of the heat pump whether you could install it or not. And I think you can also use things like overnight noise reduction mode. So now you can set your heat pump so that it only operates at a third or 40% of the maximum power at night. So I think there are lots of ways we can get through this. But I think part of what we're going to have to do is to recognize that through things like gas boiler flues, we already tolerate noise to heat our homes. So we're going to have to tolerate noise to heat our homes. This is just a different source of the noise. And at the moment, we just treat them, as if the gas boiler it doesn't matter that it's making noise, but somehow when it's a heat pump, it matters that it makes noise. And I think it's completely bonkers.
Yeah, the same is true for the air conditioners. They make noise as well.
Mm,
And what you were saying in the US, I don't know how it's called, but the system which heats the air or cools the air, which is kind
yeah,
of central heating,
yeah.
it makes a lot of noise as well. So whatever we do makes noise.
Yeah, and I think there are, in all of this stuff, and I think we're in a world generally around kind of the energy transition where this whole issue of planning is becoming a massive roadblock. And I actually wrote to I have a brilliant local MP, Daisy Cooper, who's the MP here in St Albans, and I wrote to her, explaining these problems, and she did table a couple of parliamentary questions in relation to these planning issues, which sort of inevitably got a little bit brushed off by the relevant department. But I think actually that was another example. I mean, going back to that pledge I signed several years ago, one of the things that was in that pledge was to kind of talk about it, and by sharing my blog with my MP. That was a way of just dropping a little signal into the political system that we need to get some change here.
Very good. We came to these issues of the barriers and what has to be changed at government or municipal levels to make it easy.
Yeah. So if you look at the barriers, I think, for individuals installing heat pumps is that there can be a significant capital cost up front. Okay, so there's no kind of denying the fact that if you're going to install a heat pump system and replace a gas boiler and do potential changes to your radiator system to accommodate that, because you might need slightly larger radiators, it's going to cost you £10,000 to £15,000, right? So for most people, that's a crazy sum of money, and even if their bills were lower in the future, it would be too much to invest for a future saving in bills. So I think we need to find ways to get the installation costs down. Although most of what the British government announced last week around net zero commitments was a bit disappointing, I think one of the positives was that they were increasing the boiler upgrade scheme subsidy from £5,000 to £7,500. And actually, at £7,500, given that heat pump installation costs will come down as the industry gets better at doing it, I think it does potentially make the net upfront cost within the zone of what is manageable for more consumers. So I think making that capital cost more manageable, and I think enabling things like heat as a service from the heating industry, the power industry would help with that. I've talked about planning already. I think we just need to align planning rules with the presumption that we want people to introduce heat pumps so we don't put people through a whole world of pain. I think there's a really important thing around relative pricing. At the moment in the UK, electricity costs a little bit more than 3 times as much per kilowatt hour than gas. One of the reasons for that is that there are various kind of energy system and green levies that are loaded on electricity and not on gas. If we could get that ratio to be 2.5 times, as it is in some European countries, that would transform the economics of installing a heat pump, because it would mean that absolutely for certain you would save quite a lot on your heating bills, right? So not only are you now getting an improved subsidy for putting the system in, but actually you would definitely save on the ongoing costs. And all of these kind of myths around it's going to be more expensive would be just swept away. And so I think the government needs to really think about, from a policy point of view, relative pricing of gas and electricity. And I think they have an opportunity now, and Chris Starks, the CEO of the Climate Change Committee, has highlighted this opportunity, is that while gas prices are really high, as energy prices come down, we do have a choice with the energy price cap about how we allocate that reduction between reductions in electricity prices and reductions in gas prices. At the moment, the government isn't doing that, but that's a really important one. And then there's one more policy implication, which is at the moment, the government has this very kind of binary view around heat pumps. So you only get the subsidy, the 7,500 subsidy, if you rip out your gas boiler, completely dispense with it, and do all of your heating through a heat pump. Now, the problem with that is you then need to design your system, your entire system, to cope with those few really cold days in the year when the heat pump is operating at a lower flow temperature, lower water temperature. So what that means is that you generally have to have, bigger radiators, a bigger heat pump, and so on and so forth, in order to cope with that really small number of days. Whereas actually you could have a hybrid system where, you'd said to people, well, keep your gas boiler, but just put in a heat pump over the top of it, which will operate from, February to November, and then your boiler will operate in December and January. And you probably get, 2/3 of the carbon benefit of introducing the heat pump, but it would be much less disruptive because people wouldn't need to change their radiators and so on and so forth. But at the moment, there's no incentive to do that because you don't get the subsidy. So I think we need to get more flexible. And it's interesting that in Germany, for example, the subsidy scheme is based, I think, on having 65% of your heating being low carbon rather than 100%. So I think we need to have a bit more pragmatism that recognizes the barriers that consumers perceive to introducing this technology. And sorry, there was one final one actually, which I'd forgotten, which the thing that's driven me absolutely nuts about the government in the UK was David Cameron kind of removing all of the standards around new home builds. Because actually, if you're building a new home, you can absolutely design it with very little extra cost to operate perfectly with a heat pump. So why not just insist on that, right? Just insist that that's the new homes building standard. That seems to me to be a complete no-brainer.
Many elements. I guess there is another one, workforce, the people that can do the installation works.
Yeah, I mean, this is a problem as well. So the number of registered heat pump installers, and I guess also the consistency of the quality in heat pump installers. And we're in a real catch-22 situation here, because if you look at it through the lens of the installer, they have to incur costs and effort in becoming authorized and qualified to install heat pumps. Heat pump installations can involve a lot of paperwork for the installer at the moment, because the various regulations that are required to qualify for the government subsidy to install a boiler are very onerous in terms of paperwork, and for a lot of engineers, paperwork is not their strength. And so an installer thinking about whether to become accredited to be a heat pump installer then needs to think about, is it worth it? And this is where the policy signals that government sends is really, really important, because at the moment in the UK, we're in this, well, are heat pumps going to happen or aren't they going to happen? Is it going to be, is 2035 going to be a real date or not a real date? Is the government really serious about its 600,000 target? So at the moment, I think installers are facing very mixed messages. And given that most current kind of heating installers are in their kind of 40s and 50s, they're kind of thinking over a 15-year horizon for the rest of their career. So the most important thing here, I think, is real clarity of policy signals. So the government needs to set a really clear trajectory for what it's going to do on heat pump regulation. And that's where I think a much quicker requirement on new home builds would also create immediate certainty for demand in the market that would enable the demand for heat pumps to be ramped up in a way that the supply could meet. So I think it's really the clarity of signal to the market that is the big gap at the moment around creating the incentives amongst installers to build capability.
Another point that we didn't mention is the district heating, which is also possible with the heat pumps. Is there anything going on regarding this?
So in the UK, I think the short answer to that is no, not really. But in other parts of Europe, absolutely yes. And I think Germany and parts of Scandinavia, Sweden, I think use district heating networks. These can work really, really well because it means that rather than having a heat pump in every home, and they work particularly well in high density housing. So if you've got terraced housing or apartment blocks, you don't really want everybody having their own heat pump. I mean, it's not very efficient use of resources because you're building a lot of heat pumps, but you also have problems about where to site them and so on and so forth. So here, district heating networks can work by having, you have one major heat pump installation, which might be a very effectively constructed either ground source heat pump, or it might be getting its heat source from a river nearby, or it might be using waste energy in part from local industry. I mean, there's all sorts of ways in which you can then create super reuse of heat that's coming from elsewhere in the environment. And in a centralized way, you create that heat and then you distribute it in the same way that gas is distributed to homes. You can distribute heat directly to homes through either hot water circulating or other mechanisms. And then individual homes can draw off that heat as they need it. So I think they're a wonderful idea, and I think they're quite difficult to retrofit. So this is probably you can retrofit them, but the problem there is that you need to get the consent of multiple households to this strange idea that they've never heard of and which sounds very mysterious. So you have this problem about getting consent. But I think they are a particularly the things that housing associations look at, for example, where they can retrofit them when they have control of the housing. So I think they're a great option. I think in the UK we have this sort of slight sort of suspicion of these sort of European collectivist, almost socialist schemes, and we want control of our own heat. So it sort of feels something that might be difficult in UK culture to do, but maybe I'm being too pessimistic. But I think they are actually a great idea for high density housing.
And so, when you're saying this suspicious attitude, is it from individual people or even at the government level?
Well, I mean, I think it's one that's permeates a certain strand of British politics. I think certainly on the right, there's this sort of nanny state thing about the state or local government controlling how or when we get our heat, which is of course a total nonsense because we don't all generate our own electricity, and we've come completely used to the idea that we draw it off this kind of massive infrastructure that's been built by the government on which we're all jointly dependent. So why should heat be any different?
There is another solution that was used at some point in France, which is zero interest loans. Do you think this is something that could be good to apply?
Yeah, and there are some mortgage providers that have looked at that that provide. I think NatWest, for example, provides zero interest loans for improving, insulation in homes, and you could do that. I think it's a nice idea, but I think that I'm not sure that it's the interest that really puts people off. I still think that people would be quite wary of taking out £10,000 loans to put in a heat pump. I think now that the subsidies increased, if that loan was a little bit less, yeah, maybe. Personally, I think it's kind of more likely to be successful if we have kind of companies providing that finance and taking on the risk and doing it through heat as a service. But I don't know, how did it work in France? Was it? I haven't looked at these schemes.
Well, actually, it didn't work well. So it was introduced in 2005, and there was another one introduced a bit later. The paper that I saw says that actually it failed,
Right.
potentially due to the fact that at some point banks were not interested in promoting this kind of loans because they could sell their own products for the same project.
You could require, you could, I mean, given that governments don't really like imposing stuff directly on consumers, right? We need to find intermediaries that we can impose stuff on as a channel. And, maybe you could have a regulation that, required banks to offer interest-free loans up to a certain amount for home improvements on homes that were below a certain standard. I mean, I guess, the reaction to that would be people saying, oh, well, this is going to increase everybody's interest rates and we've got a cost of living crisis, et cetera, et cetera, et cetera. And I think the bit that is challenging around pumps is that I'm delighted with my heat pump. It works great. It heats the home in a much nicer way. You don't get this kind of heating up, cooling down. It's just lovely. It's like being in the Mediterranean all the year round. It's cheaper to run. But the thing you can't deny is that there is a significant upfront capital cost in installing them. And we have to find a way to help consumers bridge that, really, really materially. And I'd like to see, the government being even more ambitious with the loan and saying something like, do you know what? For the next 200,000 heat pump installations, we're going to pay £15,000 or something. I mean, let's because I think once we get the volume of installations up, the costs will come down. And I'm really confident that in the next decade, with improving technology, and we will more and more get to the point where actually heat pumps can operate at high temperatures efficiently enough that we can just bolt them in where a gas boiler was. But the point is, if we don't prime the market, and installer skills will increase and installer costs will come down. But if we don't prime the market, that won't happen. So I think we need to do something to just convince people that this is a reality, that we are going to have heat pumps in their millions, that this is a market worth going at, and then I think technology will take over.
That's what happened with the solar panels. At some point, Germany invested significantly.
Yeah, we've got to thank the Germans for that, right? I mean, the German people invested a lot of public subsidy in getting solar panels working, and now they're a complete financial no-brainer.
I looked also at the subsidies a little bit across Europe. The amounts vary significantly from something like 1,000 euros, maybe in Italy. I don't quote me on this, but it really varies, like from about 1,000 euros to about 15,000 euros in Germany, like from at least the resource I saw. And one country which surprised me, okay, we can expect Germany paying that much, but Lithuania also offers up to 15,000 euros of subsidies.
Yeah, I mean, I guess I mean, so certain countries are going to be viewing this as a security of supply issue. I mean, they have different reasons for getting off gas, but also I think. I mean, I know nothing about how the network works in Lithuania, but one of the reasons why in a lot of Scandinavian countries you've got a lot of heat pump usage is that if you've got archipelagos and you've got a lot of islands, and actually, gas mains obviously often don't work very well, and it's actually often much cheaper and easier. So if you've got things like oil fired heating, then often it's much cheaper to run off an electric heat pump. So sometimes the economics varies quite a lot. If you're in Italy, given that it often doesn't get very cold in Italy, you can probably pretty much swap out a heat pump for a boiler without changing your internal emitter system, your radiator system, because you're never having to calibrate the system to deal with these really cold temperatures. So each country is going to be a little bit specific, which might affect the subsidy regimes. But I think the real win is going to be when we get it. Heat pumps are getting more and more efficient at higher and higher temperatures. So my heat pump can heat water to 70 degrees. Its efficiency is not brilliant at that, but it's still over kind of 2 times. It's not at the magic 3 times. But I believe we'll get to the point where these things work well enough that all you're saying to people is, when your gas boiler breaks, you just plug in a heat pump instead. So you're not having to change your pipework, radiators, any of that kind of stuff.
Absolutely. Are there any other potential problems? Like, is there any use of critical metals involved in heat pump construction or anything else that is not on the surface?
Yeah, I mean, so as I understand it, there's no particular kind of environmental impact to difference between heat pumps and gas boilers, and I guess one of the ones has been refrigerant gases, which has been a worry in the process of moving heat, exactly like a fridge. Heat pumps use refrigerant gases, and some of those, if they leak or when the heat pump is disposed, can have a massive kind of global warming impact compared to carbon. So you have to be very, very careful about what refrigerants you're using in these devices. But actually, technology is getting those refrigerants down to a pretty low carbon impact. So I think that's probably moving into the past as an issue. I think the biggest issue is the implications for the energy grid, and and I think that there are some people who are very concerned about the transition, and that we should be moving quickly to the transition, who believe that we're creating a potential problem for ourselves, because if everybody moves to heat pumps, peak electricity demand is going to get so enormous that we're going to have to build a level of renewables that is, simply, inconceivable, right? And that is why we should be looking at alternative approaches like hydrogen boilers or green gas, and using the existing gas grid. And I think there's some merit in these concerns, because I think, the heat pump usage is predicated on I think it's roughly the electrification of the economy is predicated, I think, on a tripling of electricity capacity. And we know we're finding it really difficult to get the permitting to build this stuff. So I think there is a genuine concern about whether we can build the grid capacity sufficiently to cope with all of this. Notwithstanding that, I think we're miles off that problem. I don't think we should be dogmatic and say that heat pumps are the only solution. We know that hydrogen boilers are miles off being an answer here, but there may be role for biogas, for example, in certain areas. So let's not rule these things out. But I think it's really, really clear that heat pumps are going to be a big part of the answer. Even if they're not 100% of the answer. And as I was mentioning before, I think the way heat pumps work through this sort of slow and steady heating approach means that they can also be used in demand management. So, I think that actually sometimes people sort of do rather naive calculations of peak electricity demand by simply translating maximum boiler use into what you'd need to get for a heat pump, and assume that everybody's going to be doing it at the same time. And then suddenly we need this kind of massive grid capacity, whereas actually just a little bit of demand smoothing reduces quite a lot what you need. So yeah, there are genuine issues, but heat pumps are so clearly going to be a significant part of the answer that we have to find ways to accelerate their adoption. And I'd say, having gone through it, so yes, I'm lucky I've got the resources to be able to kind of swallow the capital cost that was involved in resourcing it. It actually heats the house in a much more pleasant way, and my family's delighted with it, right? It's actually working better than the old system was working.
Okay. Thank you very much, Tom. Any other final remarks you would like to add?
So I would say, for people who are thinking about dipping their toe in the water, I'd say, go for it. It's been a fascinating experience. I'm going to be writing a piece shortly on things I wish I'd known when I started, which hopefully will help people navigate it a little bit more smoothly than I did. But I don't regret it at all. I think it's been a great way to contribute to reducing my carbon impact.
Thank you very much. That was super informative, and I also hope very helpful to many other people who are hesitating about installing it or just even learning about this technology.
Thanks a lot.